And welcome back as we go ahead and dive into our next lesson on arrays. Today we're going to go ahead and discuss a little bit more in depth the length instance variable. So in Java, an array is an object, and like other objects, it might have instance variables. And as it turns out, an array has only one public instance variable, which is named length. This instance variable is automatically set to the size of the array when the array is created. So if you create an array as follows, double score equals new double 5, then score.length would have the value of 5. Now the length instance variable can be used to make your program clearer by replacing an unnamed constant such as 5, whose meaning may or may not be obvious, with a meaningful name such as score.length. The length instance variable cannot be changed by your program other than by creating a new array with another use of new. So therefore, if we had the following, like score.length equals 10, this would be legal because you're not redefining it. You can't change, for example, how long that array is after it's been created. So here's a quick tip for you is that we want to have this length variable be used for when we have things like for loops. So the for loop below illustrates a common way to step through an entire array using for loops. If you look here, we have for index equals 0, index is less than score.length. And notice we're not predefining the size of the array. Index plus plus, this is not a print line, score index differs from max by max minus score index. Right. The inside of the array doesn't matter as much as looking at the header of the array here, because this is really helpful, especially let's say we were to have the user define the size of the array. And we say, please enter a number to indicate the size of the array. And let's say they type 10. Well, if they typed a value, we would no way of knowing how this could be. And yes, we could, have that variable be a parameter here. But if let's say we set up that variable to handle the actual array size, we can just use score.length here or array.length or whatever the parameter is going to be in order to handle that accordingly. Now the for loop is very ideally suited for performing array manipulations because of the way it's set up. It can very easily iterate through. Can you do it with other loops? Yes. But for an array, the for loop is probably the best option that you're going to use. Now there is a pitfall when we start looking at using arrays, and that is that array indices start at 0. Now the indices in an array always start at 0. Remember we said array always starts at 0. And the end with the integer that is 1 less than the size of the array. So if you think about it, that's like the array length minus 1. Therefore, when we have things like our for loop, we would say like I is less than array.length or I is less than or equal to a length minus 1 to avoid going out of the array bounds. And you might be wondering, what's the array bounds? Well, good question, because the next thing to worry about is going out of bounds, the array index out of bounds. The most common programming error that can be made when using arrays is attempting to use a non-existent array index. This is what's referred to as going out of bounds. So if we look at the following here, we have an int array a equals new int 6. When we are using this array, every index expression must evaluate to one of the following integers, 0 through 5, because remember arrays, again, start at 0. If your program contains the index variable a of I, then I must evaluate to one of 6 integers, 0, 1, 2, 3, 4, or 5. If it evaluates to anything else, that is an error. Because, again, it would be out of the bound of the array. And it's always going to be in this order, 0, 1, 2, 3, etc., all the way up until the last value. It's never going to be like a double value, because, again, these are integer values representing the place. They're always going to start at 0, so you always know it's going to start with a count at 0. Now, when an index expression evaluates to some value other than those allowed by an array declaration, the easiest thing that happens is the job is simply going to come back to you and say that array value is out of bounds. So if your program attempts to use an array index that's out of bounds, then your program is going to terminate and have an error message. Now you'll note that this error that we get, this array index out of bounds, is a runtime error message, not a compiler error message, which means you won't discover it until you actually run your program. Array indices get out of bounds most commonly typically at the very first or the very last iteration of the loop. They'll process the array, because a lot of times that's where the check is going to fail. It can sometimes occur more in the middle, but most times it's going to happen near the extremes. So it pays to be careful and check all array processing loops. Be certain that they begin and end with those legal array indices. So let's use that to kind of talk about how we can initialize arrays. An array can be initialized when it is declared. When you're initializing an array, that means that the values for the various index variables are enclosed in braces and separated with commas. So the expression with braces is placed on the right-hand side of the assignment operator then. So in this variable expression here with the array, we have int array age, and then we can see we have the values 2, 12, and 1. The array length, or the size, again, is automatically set to the number of the values in the braces. In this case, the length would be 3. If we want to look at this declaration in another way, this is very much equivalent to saying the following. Int array age equals to int 3, age of 0 equals 2, age of 1 equals 12, and age of 2 equals 1. These two expressions are equivalent. Now, there are times when using one or the other might be more helpful depending on your situation. Most of the time, we might start with this, and then we might use, for example, a for loop to fill each of these individual values, because instead of saying 0, 1, 2, we might say I, and then it's going to be whatever happens during that iteration. But there are going to be times, of course, when we may want to predefine those values of the array and then go from there. So if we want to do this with a loop, how can we do it? Well, if we want to use a loop, we typically use a for loop. So here we have a double array. So a double array reading equals new double 100. And of course, we have a variable called index that's going to keep track of our position. So we're saying index equals 0. Index is less than reading.length. Again, we're using that length instance variable here rather than relying on 100 because it's, again, better for when we're working with arrays. And then index plus plus. And all it's going to do is say reading of index equals 42. So in this case, it's going to set the value 42 to each of those values. So that means at a reading of 0, it'll be 42. A reading of 1, it'll be 42. So on and so forth, all the way up to the end of the array. Now, if I wanted this to, for example, be user input, I could easily replace this 42 with like a kb.next double, and that would satisfy that to get user input to fill every value of that array. Now, you could also have to understand that arrays can use automatic initialization. If you don't initialize the elements of the array, notice you don't come through and say, oh, this is 2, this is 15, this is whatever. They will automatically be initialized to a default value for the base type. For numeric types, the default value is the 0 of that base type. And if you, let's say, using doubles, then each element of the array will be initialized to 0.0. Very important distinction there because, again, 0.0, remember, is a decimal type. For base type char, the default value is the non-printable 0th character. Char 0, not the space character. All right, it's just non-printable. It won't show up to your screen. For Boolean, the default value is false. And for class types, the default value is null. And here we are, we're in Eclipse, taking a look at another example of that array of scores. So this is the same program as we saw before, but it has a few slight differences. For example, you can see now we're passing in doubles, and we are going to go ahead and, again, do a lot of those same calculations we saw before. So let's just go ahead and give this a run. So if we do 5 scores, just like we had last time, so I'm going to go ahead and pass those in. We, of course, get 4, 3, 2, 1, 0, because, again, the calculations are the same. But, again, we want to point out in here how these work. One thing I'm going to show you real quick is what happens if I change this index to 0. All right, what's going to happen if I do that? So let's just go ahead and run this. I'm going to put the same numbers in, 1, 2, 3, 4, and 5, and I hit enter. Oh, notice the program is still going. All right, it waited for one more value there. All right. So let's just run it again from the top, so as you can see that 1, 2, 3, 4, 5, 6. Okay, notice it took in 6 values because what happened? Well, if you remember, this originally took in score of 0. And because this is going to the score length, that, of course, inadvertently caused it to go and get another value. And so what happens is then it overwrote that initial position. So we get 2, 3, 4, 5, and 6. Even though a lot of our other calculations look very similar over here, the numbers that we're passing into that array are not the same. If I were to change this back to 1, and let's take this now, let's say so score length minus 1, what's going to happen now? So let's go ahead and rerun this. And I'm going to do 1, 2, 3, 4. And notice it has stopped now, because now our array is not taking in enough values. So now we are only getting in 4 scores. And again, that's because I truncated this length. So having the correct value in here is very important. Now, if I want to look at this array down here, and this one, of course, gives us 5 printouts. If I were to change this to 1, that's a very common mistake to make, is if I run this, I'm going to get 5 scores, because of course we fix this back, but notice we only get 4 printouts. And you'll notice that we don't have the value for 1, because when we say index at 1, it's going to skip over that first value in the array and never display it. And so we will never see that. In fact, if I were to simply just come in here, add a print line statement, and have that print line simply just print out the index is, and then we can have that print out what is score of index, just so we can see that. One of the things you'll see, and when I go ahead and run that program, 1, 2, 3, 4, 5, hit enter. All right, we get the highest score is 5, the scores are, and we get our original statement, and we get index is 2, index is 3, index is 4, index, etc. Which, of course, has us a slight problem, because that tells us that we are missing a value here. Now, as we can see here, but if we had numbers that weren't 1, 2, 3, 4, 5, then that could be a lot more problematic. But now, if I switch that back, we, of course, now have 5 values. And so that's a quick way for us also to start testing if we are not getting the correct output for our array. We would check, of course, our parameters up here, but we can also use simple debug statements like this to kind of help us to see, are we actually getting the correct iterations and what we're expecting to happen within that array.